Yeah, today we'll start the next part of the sound chapter. The next part of the sound chapter is uh, actually in the last class we completed up to frequency. Understand? So based on the frequency of the sound, we divided sound as a three types. Understand? Three kind of sound we have divided. Those are nothing but ultrasonic sound, infrasonic sound, and next audible sound. Understand? So let's start that. Yeah, based on the frequency, sound is divided in three types. First one is ultrasonic audible sound. So write down. First one is what? Audible sound. Second one is what? Ultrasonic sound. Second one is what? Ultrasonic sound. Ultrasonic sound. And third one is infrasonic sound. Infrasonic sound. Okay. So this is the way based on the frequency that we have divided three types: audible sound, ultrasonic sound, and infrasonic sound. This is based on the frequency. Yeah, what you know very well what is meant by frequency. What is meant by frequency? The number of vibration per second is known as a frequency. Based on that, we divided the sound is divided as a three types: audible range, ultrasonic sound, and infrasonic sound. Here, audible range of frequency is 20 hertz, 20 hertz to 20,000 hertz. The range of audible frequency is 20 hertz to 20,000 hertz. Okay, na? Same way, ultrasonic sound. What is the range of ultrasonic sound? More than 20,000 hertz. More than 20,000 hertz sounds known as a ultrasonic sound. And what is mean by infrasonic? Less than 20 hertz. Less than 20 hertz sounds are called infrasonic sound. Okay. So here this is the way based on the frequency range we divided the sound as a three ranges. First one is audible range, second one is ultrasonic sound, and third one is what? Infrasonic sound. So here audible, what is the range of audible frequency? 20 hertz to 20,000 hertz frequency is audible. So if any vibration, if this any vibration is between these frequencies, then only the human can hear. Understand? Any frequency between these any vibration between these frequency, then only human can able to hear the sound. If it is more or if it is less, the human cannot identify the frequency because the human ears are only vibrate for these frequencies. Eardrum of the human is only vibrate for these frequencies since they know so that these frequency of sound only the human can hear. For example, my hand is vibrating. When my hand is vibrating, already you know every vibrating body produces sound. But here, when my hand is shaking, is the sound is coming? Are you able to listen this my sound? My hand shaking sound? Is it audible? Because hearable, not audible. Why it is not audible? Because the frequency of shaking of the hand is less than 20 hertz. Less than 20 hertz, so that we cannot hear the sound of this vibration. Even, for example, a sherb, a herb is vibrating due to the blow of air. A herb is vibrating due to the blow of air. Then you cannot hear the sound of the vibration of the herb, because when the herb is not vibrating in this range of frequency, so that we cannot audible for that herb sound. Next, same way, ultrasonic sound. So what is this ultrasonic sound? Ultrasonic range more than 20,000, more than 20,000 frequency, more than 20,000 frequency range we will call as ultrasonic sound. Understand? Here this ultrasonic sound we cannot detect because the ultrasonic sound is range is more than 20,000 hertz. Since our eardrum cannot vibrate for these ranges, since we cannot hear. Even one more range we have, that is infrasonic sound, that is 20 hertz. That is less than 20 hertz. See, if this is less than 20 hertz, infrasonics also we cannot hear because these sound waves frequency is less than 20 hertz audible range, since we cannot hear. But here some of the animals will produce the ultrasonic sound. Some of the animals will produce the infrasonic sound. Here bats, bats and some of the other animals, bats. Next one is what? Dogs can identify the ultrasonic sound. Okay, that is the reason earthquakes and seismic waves can identify by the bats and what? Dogs. And even who will produce this infrasonic sound? Generally, the rhinoceros will produce this infrasonic sounds, and also elephants, heavy animals are producing this infrasonic sound. So this is all about frequency ranges based on this is the ranges based on the frequency. Okay. Now here some of the important things we have: uses of applications of ultrasonic sounds and applications of infrasonic sound we have to discuss. So better write down applications of so see here we have applications for ultrasonic sounds. Applications of ultrasonic sound. Where we use these ultrasonic sounds in our daily life? Can you tell me where we will use this ultrasonic sound in our daily life? Yeah, easily we can say the applications. First application is what? In medical field, if I say, to keep the ultrasonic sound scanning. Okay, we'll use sound ultrasound scanning. Actually, the ultrasound scanning is having big setup. We'll send this human into a chamber, so that it will scan our human organs. So actually, in this pandemic situation, the ultrasonic sound scanning is having a good good diagnostic usage for this pandemic, because it will scan our lungs. With that, we can identify how much the lungs are affecting with these viruses. We can identify by using the ultrasonic scan. So that is the main one of the important in medical field. Not only that, if you see in the case of industries here, medical field, what is the use here? Medical field. In medical field, we'll use this ultrasonic sound Ultrasonic sound is what? Ultrasound scanning. Ultrasound scanning. Ultrasound scanning. Scanning to identify, to see inner organs of human. Next, if you see the industrious uses, medical uses are what? Ultrasound scanning. Next, industries uses. Industry uses are what? To determine the flaws in the machinery. To determine the flaws in the machinery, will use this ultrasound scan. So what is it in industry's purpose? What? To determine flaws in the machinery. The machinery will use ultrasound. Next, in the ocean technology, it is very useful for sonar system. Or else here we'll use for sonar system. What is mean by sonar here? Sonar is nothing but sound navigation. And ranging. Where we'll use this sonar? We'll use this sonar in the ship technology to identify the depth of the sea or to identify the submariners in the sea. We'll use this sonar technology. This sonar technology is also based on the what? Ultrasounds. Okay. Next, not only this, here many users we have. The many users are what? Still, even we can I mean in the medical field, even we can reduce the what we can call cancer cells. To reduce the cancer cells or to reduce the unwanted cells, we'll use ultrasonic sound in medical field. So this way, so different uses we have for this ultrasonic sound. That is the reason it is a very important invention in our humankind. Next one, let's see applications of infrasonic. Let's see applications of infrasonic. This one. And not only that, in the industry purpose, to make the holes for heavy metals, to cut the heavy metals, we'll use this infrasonic. Understand? To make the holes for heavy metals, to cut the heavy metals, in industry purpose, we'll use the what? We'll use this ultrasonic sound. Next thing is uses of infrasonic sound. Applications of infrasonic sound. Applications of infrasonic sound. What is the applications of infrasonic? So the first one is, what is the use of this infrasonic? Tell me. Do you have any idea? Generally, actually, normally these infrasonics will use for a remote controls. In the remote system, we'll use this infrasonics. In remote system, we'll use infrasonic, and not only that, you know very well, to take the pictures with a camera, will use this infrasonic sounds to take the pictures, in dark room, will use infrasonic, or to develop the films, to develop the film, films will use infrasonic sound. Okay, these are the uses. Next, and to identify the volcanoes eruption, helicopter monitoring also will do with this infrasonics. Helicopters monitoring, and to identify the thunderstorms. Next, to see the environment, to see the environment, will use this to see the environmental study, will use this infrasonic sound. So these are the main applications of what? Infrasonic, and these are the main applications of what? Ultrasonic. So here infrasonic sounds and ultrasonic sounds are very useful for mankind, but here for more time, if you expose it to these sounds, the human can have some issues with these infrasonics and ultrasonics. So for major time you cannot expose to these ultrasonic sounds and infrasonic sounds. For testing purpose it's okay, but you should not expose more time for this infrasonic and ultrasonics. This is the main criteria. Next concept is reflection of light. Better write on reflection of light. Next concept is what? Reflection of light. So based on the reflection of light, we have many applications. What is mean by reflection of light? First of all, so already you know reflection of light. So it is not reflection of light, reflection of sound. Sorry, reflection of sound. So here already you have seen that reflection of light. What is mean by reflection of the light? Any light ray, when it is instant on the surface, it will bounce back to the same medium, is known as a reflection of light. Same way here also, sound also follow the same rule. When any sound wave is instant on the surface, what could be happen? It will reflect into the same medium. Okay, so the phenomena is known as a reflection of sound. What is the reflection of sound? Any sound wave will incident on any surface, the sound will bounce back to the same medium. This phenomena is known as reflection of sound. So here very important point is, generally when for the case of light, to get a regular reflection, the surface must be very smooth. Understand? To get the regular reflection, to get the proper reflection of light, the reflecting surface must be very smooth. But whereas to get the a good reflection of sound, the reflecting surface must be have rough surface, so that it will give the a proper reflection. So the main thing is, I need to follow the all reflection of light properties, okay, which means that incident angle, reflected angle must be same, and also angle of incident, angle of reflection will be equal. So here the sound, reflection of sound also will follow the same rules as like light. So that point also write down. Reflection of light, reflection of sound will follow same rules as like light. And to get a proper reflection of sound, the surface must be very rough, so that you will get a proper reflection. These are the important points related to what? Reflection of light. Out done. Next, applications of reflection of light. Next concept is, can I take out?
Sir, 1 minute.
Yeah. Next, based on the reflection of light, we are having sonar system. Applications of reflection of sound. Very first application is sonar system. What is mean by sonar system? Sound navigating and ranging. Sound navigating and ranging is the sonar system. So what actually this is used in to identify, to detect the depth of the sea. Okay, this system is used to identify the depth of the sea. This is works on the reflection of sound. This system is works on the reflection of the sound. But how this sonar will work? How we can identify the depth of the sea by using this sonar system with the help of the reflection of sound? Let us see. For example, this is a sea. Let us take this is a level of the sea, and here we have a ship. This is a ship. Imagine this is a ship. In this ship we have a sonar system detector. This is a sonar system detector, and one is detector, one is sonar waves. It will really actually it will have one. It is having one receiver, and the ship has one receiver and one producer source. The source is releasing the sound in all directions. The source, this is a source, this is a detector, the source is releasing the sound. Actually, what kind of sound it will releases? Ultrasonic sound it will releases. And let me take, this is the depth of the sea. Depth of the sea. When the source is releasing the sound waves in all directions, even the ultrasonic sound will move in the direction of the sea. In the direction of sea. So whatever the direction of the sea, they travel in the direction of the sea, and it is the depth of the sea and reflect to the backward direction. When it is reflect to the backward direction, this detector will identify the reflected sounds. But here they will observe the time lapse between the sending the sound wave and detecting the sound wave. They mention here they observe the time lapse. The time lapse we can take as a t. And here let us take this distance d is the distance. For example, d is the distance of the depth of the sea. To travel this depth, how much time taken? T time taken. Actually here, how much distance traveled by the sound here? For first time is, it will go this way and reflect back this way. To travel this total distance, how much time taken? T time taken. But how much is the total distance traveled? Total distance traveled is by the sound is 2D, because one is for downward direction, one is for upward direction. Total distance become 2D. To travel this 2D distance, for the sound, how much time taken? T time taken. Already, when they are sending the sound wave, they know the sound velocity. Sound velocity. So velocity of the sound, let me take as a v. You have velocity, you have distance, you have a time. Then you can find velocity is equal to distance by time. Then distance is equal to from the above relation. The distance is equal to velocity into time by 2. So this way we can identify the depth of the sea by using the sonar system. So this is the way the reflection of sound is helping you to know the depth of the sea by using the sonar system. So this is your today's topic. In the next coming classes, still more applications we need to discuss for the sound. For today, I'll stop the session. Okay, na? Bye.